Dancer and Prancer and Vixen, Comet.
Stop,
Cupid,
Rudolph. Out.
Donner,
The rest of you
Blip.
too. Go. Out. We are not doing that. Good grief. Merry Christmas, everybody. Hope you're enjoying the snow. And today is Monday, November 30th. It's not even December yet. And it's snowing. Of course, none of you know that because you're still in bed sleeping, most of you. Okay, first thing I'm going to do today is we're going to go back and review what's called vertex form. Some of you had trouble with that in the quiz, so I want to go back to it. Whenever you have to get it in vertex form, what you're going to have to do is complete the square by putting a blank here and then a -7. So all I've done is just put a blank where the -7 was and move that over here. Half of 4 is 2, and 2 squared is 4. So I have to add 4 here. Since I'm doing the same side, I'm going to subtract 4 over here. So I end up with x plus 2 squared minus 11. So that means that my vertex would be at -2, -11, and I'm done. So that's just a real quick review. That tells me in my parabola that that's where the vertex is at. And this tells me that it opens up. Okay, so that's from last week. Today what we're going to learn is about complex numbers. Complex numbers are anything that has I in it, which I is short for imaginary, but it's by definition, it's the square root of -1. And you guys, they just made that up because they ran into imaginary numbers, and so they just started to deal with it, and this is what they did. So this is the definition of what I is equal to. So if I take square root of -1 and I square it, and it means the square root of -1 times the square root of -1. And because the square root of -1 is I, this means the same thing as I times I, which is I squared. So I just want you to see that a little bit, how that works out. And then there's the I cubed and so on, but we won't go into that today. So if I have to do this problem, the easiest way to think about this is to take the negative and put it outside. So this is equal to the square root of -1 times the square root of 16. It's those two things put together. Well, the square root of -1 is I, and the square root of 16 is 4. And so the correct way to write that is 4i. And I hope that makes sense. It's just when the negative's inside the square root. So here I've got a negative inside the square root again. Whenever you see that, I is going to be in your answer. So 50, we need to break that down. So 50 breaks into 5, 10, 2, and 5, which means a 5 is going to come out. And I is going to come out because there's a negative right there. And then you're going to do square root of whatever's left, which is 2. And that would be the correct way to do that. So you can see that whenever there's a negative sign, you're going to end up with the I on the outside. Okay, here's another one to see here. So 40, I've got a negative, so I know I'm going to have I in my answer. And I'm going to take 40 and break it down. So 40 breaks into 2, 20, 2, 10, 2, and 5. So there's 2 2's. So what's going to come out is this. I'm going to have -1/2. I am going to have a 2 come out. Because of the negative inside the square root, I'm going to have I come out. What's left in is 2 times 5, which is 10. So it'll be the square root of 10, because that's what's left inside. Well, -1/2 times 2 would be -1, so it would be -I times the square root of 10. I know it's kind of weird, but it's not that bad. So let's just do this one a little simpler. Square root of 49 is 7, but it's got a negative on it. So this would mean the same thing as 3 times 7i, which would equal 21i. You're done. So I'm hoping that makes sense to you. Does that make sense? Let's see. Okay, that's example 1 in your book. So what I've done is gone through your homework, and I've set it up by example 2, example 3, example 4, and example 5. So example 2 would be to solve this equation. By the way, this should have been a negative right here, so I'll put a negative in there. So to do that, you would take the square root of both sides. And with square root of both sides, you get x equals, the square root of 36 is 6, but there's a negative in there, so this would be 6i. But since you're taking the square root, it's going to be plus or minus 6i. For this one, we're going to set up 9x squared. We're going to subtract 25 from both sides, because then we could take the square root of both sides. So the square root of 9x squared and the square root of 25. By the way, when I go minus 25, I should have had a negative right here. So this would be 3x equals plus or minus. Square root of 25 is 5, but there's a negative, so this would be 5i. So then we'd have to divide both sides by 3. And so we would get x equals plus or minus 5i over 3. If you split that in two parts, I don't think the book does, but it would be 5i over 3, and it would be negative 5i over 3. Okay, so that's example 2 and what you do. Example 3 is complex numbers. This one's a little bit weird. This is very important. This is used a lot in the chapter ahead. It'll be in the form of a plus bi. So if I gave you an example like that, it would be 5 plus 3i. That would be considered a complex number. The first one, which is a, is your real number, like normal, and then 3i is your non-real number because it's imaginary. Okay, now they have you solve the equation like this. And what you do is you take your two real parts, you take your 2x and equals, and then the real part over here is negative 8. And you do that equation, and then you take the one with the imaginary part, which is negative 6i, has to equal the 20y times I. And you have to solve both of them separately. So this one you divide by 2 and divide by 2. So you get x equals negative 4. This one right here, you would divide both sides by, well actually these are both i's. So I would divide both sides by I first. And then you get that negative 6 equals 20y. Then divide both sides by 20. And then you get that negative 3/10. I just reduced that, is equal to y. And so this is what they want. They want you to solve for x, and then they want you to solve for y. And that's just getting you ready for something later on. Okay, then example 4 and 5, the last two. This one says to find the zeros. When you're trying to find the zeros, remember that's your x-intercepts. So the first thing you want to do is write this as x squared plus 4x plus blank. And then we're going to put, I better do this one more step in here. Plus 13 equals 0. Then you're going to minus 13 from both sides. So we get x squared plus 4x plus blank equals negative 13. I think we're going to run into this. Okay, half of 4 is 2. 2 squared is 4, so I'm going to add 4 here. I'm going to add 4 here. So then if I put this together, I get x plus 2 squared is equal to negative 9. And then you take the square root of both sides. And what you'd end up, I'm going to have to go over here. This is going to be x plus 2 equals plus or minus negative 9. Square root of 9 is 3, but you got a negative in there, so that'd be 3i. So then you're going to have to subtract 2 from both sides. So then you get x equals negative 2 plus or minus 3i. And that's the way you want to write that. Okay, so this one's the same way, but I'm going to start it up here where we've got more room. So I'm going to write x squared minus 8x plus blank equals negative 18. So what I did was I moved 18 over here just to make this quicker. And I'm going to erase this part so I have room to come down and do this. So now I'm going to have half of 8 is 4, or negative 4. Negative 4 squared is 16. And I have to add 16 to this side. And so then I get that x minus 4 squared equals negative 2. Take the square root of both sides. And we get the x minus 4 equals plus or minus square root of 2. It's got a negative in it. So this would be actually the square root of 2. And then I would be outside of that like that because we don't know what the square root of 2 is. So once you have that, you're going to add 4 to both sides. And so you get x equals 4 plus or minus the square root of 2i. Don't put your I underneath the square root symbol because that'll get you in trouble. Okay, last one is really simple. Complex conjugates. All you do is take the opposite of the 5i here. So the conjugate would be, I'm just going to write it this way. I think the book does it the other way. It would be negative 5i plus 4. And negative 8i, the conjugate, would just be 8i. You just take the opposite sign of whatever the I is, and you make it negative. That's how simple it is. Hey, you guys, when you do these problems, please check your odds, because that way you know that you're doing them right. And if you're not, then you guys can text me or FaceTime me. Remember, there's tutoring on Tuesdays and Thursdays from 11:45 to 12:45 right here in the classroom, and they will let you in. Have a great day.